Okay, all right. Can everybody hear me? Awesome. Thank you so much for coming today. It's so nice outside. It just feels good. And I'll mention it again, but the stargazing tonight should be fantastic. I want to welcome to our live stream audience that Denon is working over here. So there are more people joining us that aren't in this room. I'm Allison Foudy. I officially start at the Hailey Public Library next Friday. I mean, I've been there a little bit, but I'm super excited to be here tonight. And quick reminder, cell phones, if you have one, I just did it, just in case. So a very big thank you to our partners for this series that focuses on space and astronomy, the Idaho Dark Sky Alliance, Boise State University, and Sawtooth Botanical Garden. And then as a reminder, after our talk today at 8 p.m. at the Sawtooth Botanical Garden, there will be stargazing with the BSU Astrotech team, so that should be super fun and beautiful today, no clouds. It is my great pleasure to introduce today's speaker, Dr. John E. Moores, a distinguished planetary scientist, an educator, and an author. Dr. Moores is an associate professor at York University, where he also serves as the director of the graduate program in Earth and Space Science. Beyond his academic roles, he has served as the science advisor to the president of the Canadian Space Agency. Dr. Moores holds a PhD in planetary science from the University of Arizona and has made significant contributions to our understanding of planetary atmospheres and surface processes. This one takes a while. His research has been recognized with numerous accolades, including the Lausanne Innovator of the Year Award, election to the Royal Society of Canada's New College of Scholars, Artists, and Scientists, the York Research Chair in Space Exploration, the York University President's Emerging Research Leadership Award, and the Canadian Aeronautics and Space Institute's McCurdy Award. With his trainees, he has also won several NASA Group Achievement Awards for contributions to 5 NASA and ESA missions. Additionally, he's a prolific author with over 100 research articles and a new popular science book, Daydreaming in the Solar System, which there are some copies if you want them, and he already signed mine. It's a fantastic read, co-authored with Jesse Rogerson. This book creatively combines imaginative scenarios with scientific insights to explore the wonders of our solar system. Today, he's going to take us on a journey of imagination and discovery as he discusses his book. This book allows readers to immerse themselves in the environments of our planetary neighbors through a narrative adventure solidly informed by the science returned by robotic probes over the past 62 years. And I have to say, it is a really great read, and we have it at the library, but we also have it here if you'd like to, and he will sign it for you. Please join me in welcoming Dr. John Moores. Thank you so much for being here.
Well, thank you so much, Allison, for that wonderful introduction. And thank you all for coming out here tonight. It's wonderful to be up here in the mountains in Hailey. Just so beautiful driving up. My first time here, but I hope it won't be my last. So what I want to do tonight is to share just a little bit about exploring the planets and doing that with our 5 senses. So from a human perspective. And what I want to do is I want to transport you just a little bit to a few of these different environments and give you just a little taste of what they might be like. They're exotic, but they are also things that are understandable, I feel, to our own human senses. So over the next hour or so, just imagine yourself being there, listening carefully, and to try to hear the story that each one of these is telling. But before we do that, what I'd like to do is I'd like to take you back, not in space, but in time. I'll take you back in time to my own childhood to start us off. So here's a lovely picture by David Blackwood. This is called Fire Down on the Labrador. I grew up on the east coast of Canada, and there were times, when I would actually go out onto the ocean. My father would take me, and we'd go out in a small little dory in a boat. And we would go out, we would lose sight of land, and you'd be out there on the ocean with the swell. And sometimes we'd have another boat out there with us, and you would lose it between the waves. Now, there were things that you could see the whole way through, like the icebergs towering above us. And if you looked over the side of the boat, you could sometimes see things come out of the inky deep below. You could see jellyfish that would come up and then descend again. If you were really lucky, you could see something like a whale breaching and then going back down into the deep. And there's something, I think, about that kind of experience, that brush with elemental nature. It's a very sublime thing. It makes you feel like you're a small part of something much, much bigger. And this is a feeling I think that we all get with different kinds of nature. And it's a little bit of a different story each time we tell it. So what I'd like to do is to take you somewhere else so that we can have our own little brush with the sublime, maybe something that is a little bit more close to home. So what I want to invite you to do is to close your eyes just for a couple of minutes. So we'll try this experiment. And just listen to the sound that I'm about to play. So keep your eyes closed. I'll tell you what the sound is. It's a campfire. But let's think about it in terms of our human senses. So what do you smell if you're imagining yourself at a campfire? And just yell it out because no one can see each other's hands. Yep, smoke. I heard that. Especially if you're on the wrong side of the campfire, of course. Songs, yes, that's right. You've got other people around you often when you have a campfire. What do you feel? The warmth, definitely on the front. Often I find my back is cold as well. And of course, if you didn't forget the s'mores, maybe there's that you're tasting. So you can go ahead and open your eyes now. So often when we're going out with the campfire, we're under the dome of the sky. You can have a version of this tonight when you go stargazing, for instance. And there's really two things about this scene that I think are important. So the first is the idea of technology. The ability to build a fire, for instance, makes this a much more comfortable place to be, holding back the dark but still experiencing nature. Having a nice warm coat, that definitely helps as well. And maybe if you've got a tent or something like that, that also improves the experience a little bit. So our technology helps us with our ability to get out in nature, to explore and to understand. But I love that somebody mentioned song, because you're not usually alone around a campfire. There's another component to this. There's a sharing of information in song and in story in particular when you're around a campfire. In fact, some people even call human beings the story species because it's something unique that we do. So really, that's us. That's the two combinations here, that story and that technology. And over the past 70 years, we've used that technology, we've built it up, and we can do truly amazing things with it. We can go from our little campfire out to the solar campfire, this nuclear campfire, around which all of the planets in the solar system are clustered. We can go and visit the planets with our spacecraft. We can explore them and get to know them just a little bit. And you might wonder why we do something like this. Well, I think part of it is something that starts a bit smaller. So for instance, if any of you have ever had some experience with, say, a toddler, you might realize that they have a certain inherent drive to explore their environment, to go out and make the unknown known. And that desire lives within each one of us. All cultures include explorers who've gone out in the past, who've wanted to see what's over that next ridge line. And to give just one example, here's the Polynesian radiation as people traveled across the Pacific Ocean settling new islands. This is a case where you need that technology to explore. In the case of the Polynesians, it's the outrigger canoe. But also, more importantly, you need the story that we tell ourselves, the story that we carry in our own culture. So with the Polynesians, there was this desire, there was this imperative in their own story. They were people who traveled across the ocean, who found these new islands, and then moved on again. And certainly, not all of these voyages were successful, but they kept on going out because it was part of the story that they told themselves. Now, the next picture I'm going to show you definitely has a story to it, one with which maybe you're a little bit more familiar. And this is a story that, again, has an intersection with technology. You really appreciate, in a scene like this, a car that starts in the cold, for instance. Or maybe having, again, a warm winter jacket is something that can really, help with a scene like this. And again, we can think about how the story changes as we take that technology and we push it forwards. We could push it forwards in one direction, maybe to become a fashion idea. I know that there's some skiing that takes place in this town, so you've probably seen a few of these from my country. But I want to take it in a different direction. I'm imagining a spacesuit, which is just a piece of protective clothing taken to its ultimate end. And here we have an astronaut on Apollo 17 here, exploring a place that is even harsher and more hostile to human life than Canada. So this astronaut is here next to this huge boulder, looking out over the surface of the moon and taking in that magnificent desolation. This is a place where human beings have actually explored. They've sort of learned the story of the land here, have had the chance to witness it with their own eyes. But not just with their eyes. You can feel the softness of the ground and the lightness of the gravity bouncing up and down. You can imagine the grittiness of the soil between the fingers, or perhaps the sulfurous smell when you get back into your spacecraft and you take off your spacesuit. And I've got to say, I do not envy the dry cleaning bill of this particular astronaut. But again, we're not just a collection of inputs from sensors. We have sort of that processing capability, that idea of wanting to make a story out of what we're seeing. And I think an image that really, really hits that home is this one. It doesn't initially look like much. So this is Michael Collins. Michael Collins was the astronaut who didn't go to the moon on Apollo 11. Michael Collins was in the command module while Buzz Aldrin and Neil Armstrong traveled down to the surface of the moon. And this particular image is taken as he is at the furthest point on the other side of the moon from the Apollo landing site. He's probably in this minute, experiencing maybe some beeping in the spacecraft. He's got lights on him. He's hopefully hearing a little bit of, a whoosh of the air exchangers. It's bad when those stop in spacecraft. But the story here that really hits it home to me, that puts a bit of the chill up my spine, is what's happening here is that Michael Collins is becoming the most isolated human being who has ever lived. He's 3,500 kilometers from his compatriots on the Sea of Tranquility and 400,000 kilometers from anyone else. So it's interesting to imagine ourselves being in this space, taking in the readings on the command module that give that information, but really feeling what that means to us. I want to show you a few more of these kinds of images of the moon. We can imagine the joy of going for a drive, perhaps in a place with no speed limits and lots of room to go wherever you want, like with these lunar rovers. And sometimes when you have the best kind of interactions and interplay, it becomes something that is collaborative between the location where you are and the things that you want to do. It really becomes play. And this is Alan Shepard here. Alan Shepard is the first and so far only interplanetary golfer. And it was a secret thing. It was not a planned thing. Alan took the head of a golf club and a couple of golf balls and smuggled them up in his sock. And we have a digging tool here that you can see. And if you look really carefully, he's actually attached that golf club head to this particular digging tool. So he took the opportunity to take a few swings, knock those golf balls out. It's the moon, low gravity. They're going to hang and travel further. So your long game is really great on the moon. When he got back to the Earth, this was something that people had seen on the cameras and on the telecast. NASA was asked, was this a planned thing? Why did the astronauts do this? And NASA said, seriously and with a straight face, just for the fun of it. So you've got that element to it as well. And when you get to know a place like this, you know, it has significance, it has meaning. And you can imagine, you know, memory is very tied to place. There are places we think of and we can bring up the emotion and the things that we were seeing and sensing at the time. And the question that sort of led us into the book was, can we do that for other places in the solar system, other places that our spacecraft have visited? Let's zoom out from this place. Let's go back to the campfire briefly here. And you can imagine looking up from those flames and seeing the moon rising off the horizon, obscured by a few trees perhaps. And keeping in mind that this is the furthest place that lives in human culture right now. It's the furthest human beings have been in person and have come back to tell the story. So where we're going next are places no one has been before. Here are the 5 classical planets. You've got Mars up here at the top. Here's Saturn. This is Mercury and Venus. They're closer to the sun than we are, so we usually see them as crescents. And here's Jupiter. So the ancients knew about these 5 planets. They're wanderers. They traveled across the heavens in strange ways. And so they were paying particular attention to them. We also could see them with telescopes. And this is kind of the view that you get from the best telescopes that existed before we went out with spacecraft. From these disks, you can't really tell all that much. You can't get to know these as real places. It took actually going there to do that. And if we return to the ancients, we remember that there's a bit of a pull to this. It wasn't that these were just lights in the sky that moved around. The ancients ascribed significance to them. They thought that they were associated with their gods, for instance, the Romans and the Greeks, these 5 wandering stars, and they looked up to them and their motions in the heavens to try to understand what was happening down here on the earth. Now, it's really interesting to me that you have these 5 classical planets, but we also have 5 classical senses. We've got touch, taste, smell, sound, and sight. And this diagram here I really like because it describes the 5 sensors that we use to get these inputs into the brain, but it shows them all being combined in here and turned into something else, something stronger. And we can take a look at each one of these things and we can find an analog for it, something similar that we can combine that exists on our spacecraft. So for the touch, for the skin, we can think about things like robotic arms, which are intended to go out and dig into the soil. Or we can think about the wheels of our rovers. How much do they slip? How much, resistance do they get when trying to get over a rock? That kind of feedback gives us some idea of what these surfaces might be like, for instance, to walk upon or to gather up a handful of soil. For taste, sometimes we take samples of the ground and we'll put them into our scientific instruments. In fact, we have scientific instruments who look at the chemistry of these kinds of samples, and to get that chemistry, we'll bring a little bit of water along to add to the samples. So spacecraft saliva is a thing. So that is a really neat analog, I think, and we've had a couple of examples of those. We can also bring in the air that we experience on another planet. We can bring that into our spacecraft and analyze it. And we really do have spacecraft that essentially have noses made of lasers that tell us about all of the faint little chemicals in there, and we can backtrack from that as to what these places might smell like. We can hear what's going on other planets with microphones, and we can take lots of pictures to really give a good idea of the environment. We can even do selfies, lots of selfies. I'm part of the Curiosity rover mission, and we love to take the robotic arm up to take a picture back at the rover. So we've got ways of telling what the environment might be like to a human being, but we've got a problem in terms of the stories that myself and Jesse wanted to tell. And that's the problem, that for a spacecraft, being on another planet's not a big deal. For a human being, this is how you die. So we gave them a spacesuit. The spacesuit's necessary. We don't want our explorers to die. That would make the chapters too short. So we tried to think of ways that you could interact with the environment even with a spacesuit. Vision is pretty easy. You can imagine, doing, hearing and sound, but some of the other senses you have to be a little creative about. And the thing that I remembered, and the thing that came to me vividly, was thinking about the astronauts on the moon. After a day's work, they would go back in the lunar module, and they'd take off their suits. And so they would immediately be hit with this spent gunpowder sort of smell and the grittiness of that soil. So there are ways of really interrogating another planet that don't necessarily need you to be outside of your spacesuit. It's just amazing to me that we know what the moon smells like, even though the moon has no atmosphere. So we tried to look for these kinds of interactions. And what I want to do for the next few slides is to take you through these sets of classical planets, and I'm going to pair them up with the classical senses, and we can take a look at what we can discover. So I'm going to start with Mercury, and I'm going to start with sight. And it may seem a little weird to pick Mercury as the representative of vision. And the reason for that is that when we look at Mercury in true color with our own eyes, it looks pretty gray, it looks pretty featureless. I mean, you see craters and you see rays and broken up rock and stuff like that, but it's kind of lunar-like, it's very moon-like. So what is there to see in a place like this? Well, we can get a bit of a hint if we take our spacecraft vision and we pull the colors apart, we stretch them out. And what happens is that you get two different colors that you see. There are blues and there are oranges. And those are telling us something about these surfaces. The blue areas are places that are very old, that have been weathered by the solar wind for hundreds of millions, billions of years. And the orange places, those are fresher terrains, they're newer. It turns out they're actually volcanic terrains, which we didn't expect before we went there with our spacecraft. I can give you a close-up look at this just so that you can see sort of the variation really nicely. So here's a volcanic plain, and you can see on top of it craters in blue that had rims that were too high to be invaded by the flowing lavas. So they remain blue while the rest remains orange. And that gives you a bit of an idea, I think, of the differences that you can see. So the other thing, when you're considering going for a walk on Mercury, and you're thinking about what sights you might see, is your enemy in the sky, the sun. Mercury is the closest planet to the sun, and the sun is 2.6 times as large as it is on the Earth. That is just a really, really menacing presence. If you were there on Mercury at full noon with the sun straight overhead, every rock around you would have heated up to the point where you're on the self-cleaning cycle in the oven. And that's not good for you, no matter what kind of spacesuit you have. So on Mercury, the name of the game is trying to stay away from the sun a little bit. And the places that do this and do it well can make a good living. So we'll notice here that you've got these little craters. These are at the South Pole, or sorry, the North Pole. And where we see yellows in here, these are places of permanent shadow. So they never see the sun. And so when you have comets that deliver water to Mercury, or that crash on Mercury, what ends up happening is that they can hide in these shadowed regions down here. And so Mercury has actually built up quite a bit of water ice over time. Now, the other thing you'll need to keep in mind if you're going to go for a walk on Mercury is the strange pattern of its orbit and its day. So Mercury is in what we scientists call a 3-to-2 spin-orbit resonance. And that's just a fancy way of saying that every time Mercury goes around the sun twice, it rotates on its axis 3 times. And that has the net result of making Mercury's day twice as long as its year. It's 176 days long. And what this diagram here is showing that if you look at just one orbit of Mercury, you can see how this works. So here you go from 1, 2, 3, 4, all the way around. We've got a little triangle here that shows something that doesn't move on Mercury, like a mountain, for instance. And then we're imagining this tree here. We're imagining, unlike terrestrial trees that can move, or on Mercury we're going to have our tree move, it's going to stay on the division between nighttime and daytime, what we call the terminator. So it's sitting there essentially at dawn. And as we go around, Mercury rotates, the tree stays on the terminator, and eventually your mountain ends up pointed towards the sun. And so you can see if you go around again, you'd get all the way back to the start. So that's the situation that we have on Mercury. It gives you a lot of time to make your way around. So in the book, we thought about maybe we'll do a trail on Mercury. We'll walk all the way around the planet. 176 days helps with this. And we'll see the sights. So this particular trail that we put together, it's a real trail. You could go and do it if you had the technology. And it's 10,000 kilometers long, which sounds like a long walk. But the longest contiguous trail in North America that you can walk is actually 14,000 kilometers long. So there's actually people who do even bigger distances than this here on the Earth as well. We called this particular trail the Crest of Dawn because you want a little bit of light. So you want the sun just peeking over the horizon. You can do it at sunset, you can do it at sunrise, but a real Mercurian, you have to be chased by the sun, I think. And you're always having to keep moving in that scenario. You have to make miles, because if you stop, the sun's going to rise high up in the sky, and if it rises too high, you're going to have to find some shelter and suffer the ignominy of having to call for the park rangers to come and rescue you. And you don't want that. So we thought this was a lovely little metaphor, the idea that you need to savor every sight that you experience as you're experiencing it. You can never go back. You have to keep going forward. You can spend more time in a place, wait for the sun to get a little bit higher, but you've got to make up for that by making miles elsewhere. And around this circle, you're going through canyons, you're seeing lots of craters. There's a high region here where you can look out over the plains. There's even in some of these craters here, these monoliths in a circle like giants that cast huge shadows. It's a wonderful place to explore. So then we were thinking a little bit about Venus. And with Venus, we were thinking about scent and smell. Venus has an interesting dual character to it. We've got the surface, this sort of hellish landscape where the pressure is 90 times as much as it is on the Earth. And you've got temperatures here hot enough to melt lead. Because of that and the heat haze, you can only see a couple of 100 feet. It's almost like being underwater that way. And if you go up higher in this atmosphere, it's a little bit different. Up here in the clouds, 50 kilometers up, it's one of the most Earth-like environments in the entire solar system. Up here, the temperature is close to the same. The pressure is close to the same as we have here on the Earth. It's carbon dioxide, which is, not the best, but you don't need a spacesuit here. You just need a little bit of oxygen and maybe a good raincoat so that, the sulfuric acid clouds don't give you too much trouble. If you're wondering how it would smell, it's that sulfur, I think, that's the theme for Venus. You've got this idea of perhaps if you went to visit a thermal park or a fumarole, it might be a little bit like that. And there's weird and wonderful processes that we can recognize here on Venus. If you go down to the bottom of the atmosphere, to the surface, we have interesting things going on. The high temperature, the high pressure, it bakes things out of the rocks. Those materials go up, they form clouds, and those clouds will snow out on the mountains, same as here in the Rockies, except this snow isn't water snow. This is iron pyrite, fool's gold. And even galena. I noticed you had a galena street here. That is part of the snow that you get on Venus. What's really interesting about these high regions as well is that they're probably the only surviving regions from when Venus was more like the Earth billions of years ago. So if Venus ever had life, this is where you'd find the fossils. You just need to brush off the fool's gold to find them. Higher up in the atmosphere, you've got a really interesting situation because of that carbon dioxide. So I want you to imagine blowing up a balloon just with your own breath with room air, nitrogen and oxygen. If you do that here on the Earth and you take your balloon, nothing much happens to it. It might fall down to the floor because the rubber has some mass to it, but really it's not really strongly wanting to go up or down. If you take it to a place like Jupiter, Jupiter, its atmosphere is made up of hydrogen. Hydrogen is extremely light as gases go. So what's going to happen is your room air balloon is going to sink like a stone. But Venus is different. Venus has an atmosphere full of carbon dioxide, which is a very heavy gas. We know that if we have a carbon dioxide leak, that it sits at the bottom of a room. And on Venus, because you have that heavy gas, even room air, nitrogen and oxygen is going to rise. It has buoyancy, which means that if you took an envelope and filled it up with breathable atmosphere, that would be perfectly buoyant in Venus's atmosphere. If you like cloud cities, this is the place to build them. And it doesn't just have to be cloud cities. We imagined in the book this would be the perfect place for the solar system's largest, most spectacular balloon festival. So this is one of my favorite pieces by Michelle, in which she imagines these balloons coming out of one of the clouds at sunset. And you can see all the colors of the sunset, on this wall of clouds as the balloons come out and they dry off. It's really quite interesting the way that the Venusian atmosphere works. A lot of the energy from the sun doesn't make it all the way down to the bottom. It gets absorbed high up, and that spins up the atmosphere to really high speed. You can make it from one side of Venus all the way around, circumnavigating in about 80 hours. So the balloon festival would start in the day side, and then it would go through the night side and back again. So I think that's really fascinating. And by the way, I just love to think about what happens with the balloons and what it would look like after the sun sets. You don't want to lose your compatriots here, so the balloons would probably have lights on them. You might turn on the burners. And I learned a wonderful word in writing this particular story. We actually do this here on the Earth, and there's a name for it. It's called a glodio. So I thought that was such a charming term. Let's move on to Mars. And here we're thinking about taste. Taste is kind of a hard one if you're inside of a spacesuit. But Mars, in some ways, reminds us of the Earth. It's not as clement as the clouds of Venus, but it looks a lot like it. It's really, as Brian Cox loves to say, a dry and frozen version of our home. Here we imagined a couple of different stories. We imagined just sitting there, looking up at the clouds. We have clouds on Mars that look a lot like terrestrial clouds. We've got cloud streets, we've got cumulus clouds, we've got mare's tails, the cirrus streaks that I really love. But we also have different things. We have these sort of wavy clouds that move up and get expressed, and then they disappear as they fall down, as if there's an invisible mountain sitting in the atmosphere. So those we observe with spacecraft. They're really quite neat. And there's also optical displays in the atmosphere as well. You may have seen, caused by ice, sundogs around the sun here on the Earth. Maybe you even get tangent arcs or see a halo. On Mars, the ice is likely to be in a different shape, a cube instead of a hexagon. And so you're likely to get this kind of a pattern with a couple of different halos and these 4 boomerang things. It looks a lot like the Earth, but it's different. I love that exotic wrapped in the familiar. We also imagined going for a rappel. I mean, Valles Marineris is such an amazing feature, this canyon system that could gobble up 500 Grand Canyons within it, where if you look across the way, it's 60 miles to the other side of it. The canyon system is actually so long that there is nowhere on the planet you can appreciate the whole thing. You have to see it from orbit to really understand it. And to fall down this thing is 10 kilometers top to bottom, 6 miles. So we imagined doing this as an astronaut, and we imagined it takes 3 days. That's why we went down instead of going up. Makes it a little shorter. And we figured, since we actually have the topography and we have the imagery, let's not just talk about a generic rappel, let's actually pick a specific route that you could do someday. So we imagined starting up on the rim here and then going down to a couple of false summits with camps all the way to this crater down at the bottom. Now, in this particular traverse, we imagined that the astronaut perhaps found an outcropping of water ice. We see some of this at the mid-latitudes on Mars. And we imagine they might chip off a little bit of that water ice and add it to their own store of water. And what would it taste like, this billion-year-old Martian ice? I imagine it's fairly well filtered, maybe a little bit of a mineral tang, maybe a little bit of iron from all the iron oxide we see here. And what could you do with this water other than just drink it? Well, you could make coffee. We didn't want to forget about the little mundane things. When you go camping, it's not just staring in awe at mountains. There's also, packing up the tent, putting it together, making coffee, and these little social things as well. So we imagined, what would it be like to make and drink coffee on other planets? So have any of you experienced a meal on an airplane? I'm seeing some nodding here. And I'm going to go out on a limb and imagine that it was not, the highlight culinary experience of your lives. And it's not just the airline's fault. Up in an aircraft, you're at low pressure, you're at low humidity. And because of that, your sense of taste is deadened. You don't get the same kind of response. And so the airlines add salt, they add sugar, they add fat to try to make the food more palatable. And Mars is a lot like this. You would have that low pressure and that very dry atmosphere. And so it would be hard for coffee to taste very good. But if you want really great coffee, go to Titan. Titan has 50% more atmospheric pressure than here on the Earth. And we talked to folks who work with people in hospitals that use hyperbaric chambers. And we asked them, what does food taste like in there? Do you ever take food in with you, into these things? And we were told, well, yes, we do. And how does everything taste? It tastes fantastic, apparently. So the increase in pressure actually, affects the way that food tastes. You do have a problem with coffee in that the boiling point then happens at a higher temperature. So there are some modifications you have to make to your daily ritual. We wrote about them in the book. We are sure that this will be the standard for NASA whenever they land on Titan. But it's interesting just to think about how it's different doing just the mundane things of daily life. And it's interesting, I find, when people talk to astronauts, that the most popular question that comes up is, what is it like to use the bathroom in space? We stayed away from that in our book. We went for coffee instead. But I do know the one leads to the other. All right, so let's talk about sound next. Jupiter, and also its moons, primarily Io and Europa, but also a little bit of Ganymede. So this is the perfect place in the solar system to talk about sound, I think. So here, you've got a couple of different things going on. You've got this family portrait here, just to show you what we're talking about. So here's the great red spot on Earth. It's an enormous anticyclone, like an anti-hurricane, kind of, because it's going in the other direction. That's been around for at least 400 years. Galileo saw this thing. We still see it today. And we also have the two innermost moons of the large moons. We've got Io and Europa. And if we take those two and the next one out, which is Ganymede, then there's an interesting interplay in their orbits. Those three moons are what we would call in resonance with one another. So every time that Ganymede goes around Jupiter once, and that's showing in this diagram up here, with Ganymede moving around in each one of these subsequent plots. Every time it goes around once, Europa goes around twice, and Io goes around 4 times. So they're in this interesting sort of overtone, almost musical arrangement as they travel. Jupiter itself is no slouch here. It's providing the baseline. What's happening here at the red spot is we're able to see more deeply into Jupiter's atmosphere because the low rumble of this particular feature is sending sound energy up higher in the atmosphere and keeping it free of cloud. So that lets us see deeper. That's why we get a different color here. We imagined doing a free fall, doing a parachute into the great red spot, of imagining what that would be like, looking out at the horizon 1,000 miles away, and then traveling down into the cloud layers. Before you set up your parachute, you're falling actually at a speed faster than the speed of sound. The strong gravity on Jupiter, and the atmosphere is not very dense. There are multiple cloud layers. In between those, I just love the feeling of interiority, the idea that you're completely in an enclosed space, but you can look out again to that 1,000-kilometer horizon. So it's a fascinating place to imagine. The moons, we think about fire and ice. So for Io here, we imagine the most volcanically active body in the solar system and what it would feel like to watch an eruption and to feel that eruption and the sound of it through your suit. Over here at Europa, Europa is a place that is still active. Those cracks are forming today, and the sound just must be something else. So we were thinking more about this particular object, and we were imagining somebody who perhaps was in an installation down in the ice that had been cut into it with heat. And the sound that we imagined was actually something a little bit like this, of what it would be like for the sound of those cracks to propagate around. So that sounds a lot like what Arctic explorers encounter when they're feeling ice crack beneath their feet. And you get the same kind of tension, I think, of that ricochet. But that sound actually is of a toy called a Zoob tube, if you've ever seen one of these things. It's a spring inside of a cardboard tube. By the way, I think if you have a Zoob tube and a theremin, you've got everything you need for creating a science fiction soundtrack. The ice shell is just the start of what's going on at Europa. Underneath that, we have an enormous ocean, more livable volume than exists on the entire Earth. And it's a place that's habitable, but is it inhabited? We imagined our astronaut going there and exploring it in a submarine. And there's a point in the story where they see something out of the corner of their eye. They can't quite tell what it is. Our artist has an idea of what it is, though. Maybe that. So, it's a wonderful thing to imagine, I think. All right, I want to talk to you a little bit about the last sense, which is touch, and Saturn is a great place for this. Here's the family portrait here. We've got Titan, which is Saturn's biggest moon. Here's Saturn itself, and here's the ring system. The ring system is fascinating. It is really, really wide. 100,000 miles from one end to the other end. But it's very, very thin, 100 feet from the top to the bottom of this thing. And it's not a solid object. It's made up of lots of little individual particles of ice doing a celestial mechanics dance of sort. It looks kind of like this if you were to be inside of those rings, traveling around, moving in them. We've never been able to take a picture of the ring particles. They're too small. They range sort of between snowflake-sized and sort of boulder or house-sized. But we know how those rings interact with the radar waves that our spacecraft send back to Earth. And because of that interaction, we can tell how big they are, and we can tell what they're made of. They're really fascinating, this dance. So here we have a shepherd moon here, which is in one of these gaps. And what's happening is it's giving out two wakes. So you have one wake that travels in this direction. And that's the outer ring particles that are moving slower than the shepherd moon. But you can see the bit of the wake on the inside too, and it's traveling in the other direction because those ring particles are moving faster. It turns out the speed limit increases as you get closer and closer to Saturn. And these waves are like ocean waves. They're gravity waves, up and down like that. So they're vertical. But you can also have places where the ring particles get closer together and further apart. And this image here is not your TV at 3 a.m. But it almost doesn't look real. This is actually a photograph from the Cassini spacecraft showing that dance of particles getting closer together and further apart. And that creates this really interesting mathematical pattern. You do have some moons of Saturn that are just collections of these ring particles smushed together. So Hyperion is an example of this. And in the book, we imagined the kinds of caves that might be created by those particles not quite fitting together. Maybe there's even city-sized voids inside here. And Titan. Titan's an amazing place. The atmosphere is very opaque, very puffed up. It's this sort of yellow-orangey color with a beautiful little blue rim. But if you look at the right colors, unfortunately our human eyes can't see it, but our spacecraft can, then you get this vista of the surface. And what we discover is that this is a planet, well, a moon, that's covered by the largest dune fields in the entire solar system, and there are also lakes. So it's a place you can go flying, and it's also a place where you can go sailing. Boat would have to be a bit different because liquid methane is less dense than liquid water. So you need to have a broader boat to get the same kind of displacement that you would need. Because of the low gravity, you could jump up to the top of the mast to fix a problem if one showed up. But be careful about doing that, because if you fall in the water, you're much denser than the liquid methane, and you would sink. It's also 180 degrees Celsius below zero, and that's very cold. So it's a wonderful, interesting place. And you've also got this crazy stuff going on in the atmosphere. You can have a thunderhead on top of another thunderhead, and they can drop up to 3 feet of rain in a storm. So we imagined somebody running into one of these and trying to go the other way as quick as they can. One of the things I really love about Titan is that there is a lovely theory by a colleague of mine, Catherine Niche, that this body used to be covered with liquid methane. And what happened is over time it evaporated, it went up to the top of the atmosphere, the sun's ultraviolet radiation took those molecules apart and put them back together into a sort of soot, something solid we call tholin, a little bit like coffee grounds actually. And this material sprinkled down through the atmosphere and created the dunes, reassembling that ancient ocean into something that looks eerily like a frozen version of it. And you could imagine going out to this place after flying, picking up a handful of soil and letting it pass through your fingertips, this reminder of deep time and change in the solar system. All right, I want to share a bonus sense with you. And sixth sense is not ESP. I wanted to talk a little bit about emotion, that combination of things. And what we did in the book is we used the smaller bodies to explore this. We wanted to think a little bit about what it might be like to be shipwrecked on a comet. And let's up the ante. Let's make this what we call a sun grazer. That's a comet that goes very close to the sun. They don't all come out the backside. Sometimes they're irreversibly disrupted or completely evaporated by the intense heat of the sun. And so we wanted to imagine what it would be like to be at the mercy, at the tyranny of celestial mechanics and the way that things move in the solar system. We also wanted to imagine somebody perhaps who needed some space, who had gone through a difficult time perhaps and wanted to get nice and far away and do something to process. So we imagined a story on an asteroid. We figured an asteroid has all the different elements you need for life. Let's grow a rose there, do a little gardening. And this one was a bit of an homage to The Little Prince, if you know that story. We figured that growing a baobab was a bit of a tall order, so rose it was. And the last one I wanted to mention here is Pluto. Pluto is a cartoon of a planet in many ways. I mean, you know, just look at it. There's a heart on its surface, for goodness sake. And if you go to the backside of Pluto, you'll find that on that hemisphere that faces its moon, called Charon, that when you look up in the night sky, you see a full moon that's the size of 50 Earth full moons. It's like a child's imagination of a planet. It's almost a secret place that you can enjoy all to yourself. But secrets are better when shared. So this is the one story in the book that has a second person in it. All right, so let me bring all this together. We've toured the solar system. We've looked at all these other planets. We tried to understand them from a human perspective. And you might ask, why is it that we explore all the worlds like this that are huddled around that solar campfire? Is it to get their resources? Is it to build another home for humanity? Or is it even just for knowledge? Well, what we wondered is maybe it's more basic than that. If we don't go out and explore, if we don't make the unknown known, then those places just don't live in human culture. But if we do go out, if we do explore them, if we learn their stories, then we can share them with others, and they can actually live as part of us. They can be more than just abstractions onto which we paint future versions of our past mistakes. And in that way, they become a part of all of us. They enrich our understanding of the cosmos and the world in which we live. So thank you very much, and I'd be happy to take any questions you have.
If you have a question, let me know. I'm going to bring you the microphone so that our live stream viewers can also hear your questions. So if you have something, just kind of signal at me. And then the button's on. It should be good to go. Thank you.
So, despite being called a storm, is Jupiter's big red spot actually, would it be a pretty calm place to be in?
The winds are quite quick.
Yeah.
So I think it would not be a lot of fun. You'd experience a lot of turbulence flying through there.
Yeah. I was looking up information about it because we do outreach, so I didn't really know how to explain it to kids, what kind of storm it is. But when I would look it up, it would say that it's not actually that bad as a hurricane, I guess. So it's not a hurricane. It's
Well, it's like a hurricane, but the opposite direction.
So that's the only difference, is that it just spins the
and it's
other way?
very big. You could fit at least 2 Earths inside of it.
Okay.
So, and at the very edge, the wind speed is something like 500 kilometers an hour. So let's call that 300 miles an hour.
So pretty fun then.
Yeah.
Thank you.
You didn't mention the temperature on Mercury. Is it very warm?
Very warm. So the question was, the temperature on Mercury, is it warm? And it's quite warm. So and it's quite variable. So on the backside, where you've had 176 days of night, you can get down to very, very cold temperatures, like several hundred degrees below 0 Fahrenheit. Whereas on the day side, you can go up to very warm temperatures. And I do compare it, I think, to the self-cleaning cycle on an oven. So it's in that neighborhood.
Well, thank you for this talk. It's been great. As I understand, one individual's plan for terraforming Mars, there's a significant problem because Mars has no gravity, as I understand it. So I'd really appreciate your views on the possibility of this, or whether this is just more science fiction.
So Mars does have gravity, but it's a lot less than the Earth. It's about 1/3 of the Earth's gravity. But that doesn't tend to be the biggest problem. There's a colleague of mine, Pascal Lee, who likes to talk about Mars and terraforming and habitability. And he has a whole swath of different parts, different processes on Mars, and he divides them up into the things that will kill you immediately versus the things that will kill you in weeks or months or so forth. Mars is a bit of a nasty place. In the images, it looks nice, but really, the Earth after a nuclear war would be so much nicer than Mars. There's no breathable atmosphere. It's too cold. The dust, would get into your lungs and give you silicosis. And if you lived through that, the chemicals in it would get into your bloodstream, and you would have a lot of trouble that way as well. All of the different suggestions for terraforming it are big jobs, and in many ways kind of temporary. So terraforming is a hard thing to do. It would, if we chose to do something like that, it would be the work of generations at the very least.
As you were talking about everything here, you kept referring to we. So we did this and we wanted you to experience it this way and so on. But you're the author on it. So there must have been a collaboration perhaps?
Yeah, there are three of us. So I'm the one giving this presentation, but there are two of us who wrote the book, myself and another professor named Jesse Rogerson. And we also had Michelle Parsons, our illustrator, from the very beginning. So we had this interesting process as we were writing where sometimes somebody would think of some interesting science and that would inspire a story, or Michelle would, do a piece of art, and then we would think about, well, here's how we can weave something around that, vision of another place. And so it was collaborative between the three of us. It's hard to, tease apart and say, this person only contributed this and that person only that. There's a question in the back.
Yeah, when Alan Shepard died on, was it ever measured how far it got home at a tremendous distance, every 1,200 meters?
Yeah, so the question is, Alan Shepard's drives on the moon of the balls that he brought with him and used with that digging tool. He described them as going a long way. Unfortunately, orbital cameras got better, and it looks like they didn't go that far, at all. Maybe a few tens to 100 meters, something like that. So part of that is that a digging tool does not make a very good club, I think. And the other side of it is that the Apollo spacesuits were not very flexible, so it was difficult to get a lot of power on the drive. It's also difficult to turn to see, your shot as well. So it could be that Alan imagined them going a little bit further than they did, like we all do, when we hit them. Yeah, there's a little. You can see some of that, in the orbital imagery, because all of that stuff on the moon, processes are slow, so you can still see the footprints and the flags and all of that, and even the golf balls.
Thank you. I had questions on every planet, and by the time you got done, I've forgotten the questions. However, you are from York University. I'm assuming that's not in England, it's in Canada.
That's right. We are the Canadian version. There is a University of York that is in the UK, but we are totally different, despite the fact that our coat of arms has the War of Roses insignia on it.
Yes. And you mentioned working with NASA, and on one of the particular projects, how were you involved and how exciting was it?
Well, it was very exciting. I can say that first of all. I had the joy of being able to do my graduate degree at the University of Arizona, and the University of Arizona has had participation on every U.S. planetary mission that has ever flown. And while I was there, my advisor, Dr. Peter Smith, he involved me in the Mars exploration rovers. So I worked on Spirit, the problem child, not Opportunity, the golden one. I also did some work on the Phoenix mission, which went to the Martian Arctic, and I did some work on the Huygens lander, which was the first spacecraft to land on the surface of Saturn's moon Titan. And that was amazing. Those of us in the room were the first human beings to actually see the surface of Titan from the surface, from that human scale. And that's a memory that sort of stayed with me. It was exciting, but it also had a lot of, significance and meaning. And I loved that first image, that of a new landscape that we get from these spacecraft. I've worked on a few other things since then, the Curiosity rover on Mars, the Juno orbiter around Jupiter, the InSight lander on Mars. But I go back to that image, when I'm thinking about studying space exploration.
That brought up a question. Were you involved in the University of Arizona's landing of a capsule on one of the asteroids?
So I was not directly involved with that one. So that was that was the asteroid Bennu. So it's the one that I showed. I'll go back to it because it's quite close to the end. This one here. So they took a sample from this, and then they brought that sample back to Earth, which is how we know what this asteroid is composed of. I secretly picked this asteroid because we know it well. And we know the kinds of compounds that are there. We know the different atoms. We know about water. And so we know that with a little bit of processing, you could garden with this stuff. So that was the reason that we picked it. I wasn't directly involved with that, but York University did provide an instrument. And I know all of the people who were involved from my time down there as a student. So I was cheering them on from the sidelines.
It's a great book, the picture book that they have.
Oh, I don't doubt it. There's amazing vistas that their cameras have taken over the years.
I think we have time for one more. Does anybody else have one more? Any takers? All right. Well, thank you so much, Dr. Morris.
Thank you for having me.
One more plug for the book. It is a really good book. And so if you need to read it, we have it at the library. There's some copies that you can purchase. Dr. Morris has offered to sign them if you'd like that. And don't forget stargazing tonight at 8 p.m. at Sawtooth Botanical Garden. Thank you. Thanks so much for coming.